Talking about absolute value. So the x is isolated, isolate and separate. So I would separate this into x equals the positive amount, 5, and x is equal to -5. Now, there's nothing to do with those, nothing to simplify there. So my solution is just x equals, and yes, you should put it in braces, 5 and -5. Because it is not an ordered pair, we're saying that both of those values are 5 away from 0. Any questions on that first problem? Okay, now let's take a look at the second one. Is this absolute value isolated and by itself in the equation? Yes? No? No? Is it being multiplied or added to? Or is it by itself? It is by itself. Yes, it is the only thing on that left side of the equation. So it is isolated. Now you can separate it into those two cases. All right? So I know n minus 3, whatever this is in here, that has to be 4 and -4. And so that's why we set it equal to the positive amount of 4. And then we set it equal to the negative amount of -4. Because we know whatever's in there has to be a 4 and a -4. But we still need to figure out what n is. Now you just solve. So add 3, add 3. 3's cancel out. N is equal to 7. On the other side, add 3, add 3. N is equal to -1. You're like, Miss Thede, how could both of those be a solution? Well, let's check. If I substitute 7 in for n, I get the absolute value of 7 minus 3. Is that equal to 4? Well, 4, the absolute value of 4 is 4 units away. So yes, 4 is equal to 4. That checks out. Let's substitute -1 in. -1 minus 3, the absolute value, is that equal to 4? -1 minus 3. Now, if some of you have difficulty with your positives and your negatives, please make sure to get a calculator because it gets a little tricky. -1 minus 3 is how much? Are we in slow motion?
Yep.
I did say something, didn't I? -1 minus 3 is -4. And the absolute value of -4, how far away is -4 from 0? It is 4. So 4 is equal to 4. So my answer here, I wanted that in blue. N is equal to, in braces, 7, comma, and -1. Are there questions on that? All right, take a look at this last one. The absolute value of P, the absolute value of some number, is equal to -3. How would you approach this problem? Say it again. Okay, same as the first one, maybe. So is P isolated? Is it by itself on the left-hand side? All right, so what would we do? Do we separate into the two cases? Now remember, what does absolute value represent again? What is absolute value? A distance. Can we have a negative distance? Oh, but wait, this says the absolute value is -3. Can we have a distance of -3? No. So you cannot have a negative distance. So we have to remember what it is we're searching for. So there's a certain term for this. If you remember, the symbol looks like a 0 with a slash through it. We call this the null set. Or you can write it as two empty braces. Empty meaning there is no solution. Empty. And we call it the empty set. And basically it means there is no solution. That's what it means. But we don't write no solution. We put the null set. This is probably what you would see most of the time mathematically. Okay? And why is this the null set? Why don't we separate it into the two cases? Because, yeah, our distance can't be negative. The absolute value of some number cannot be negative. Okay? Any questions on those three? All right, let's go to page 16. Page 16, we were in the middle of doing and solving some absolute values. Page 16. Were we ready for D by chance?
Yeah.
Okay. Allison's not here. Ooh. You're not here? Save. Okay, I am going to start putting it up, but only use it as a check, okay? Use it as a check to see if you are getting the same value. That's not what I wanted. I know, right? What the heck? No. There we go. So again, check your answers with what I'm putting up at the front board. Yeah.
Would it be?
Seems a little large.
No.
Divide by 2. You forgot to divide by 2. But yes, the rest of it looks good.
Okay.
What's the matter? You guys laughing at my tentacles? Again, the key is you want to isolate that absolute value and make sure whatever you do to one side, you do to the other. Do we subtract? Say that again. You're just waiting? Okay. It's negative. So you set it equal to the positive amount, and then you set it equal to the negative amount. Did I miss something?
Nope.
Okay. So check your answer with what I have up here. Hopefully I'm right. I do make mistakes. I try not to, but sometimes.
Nope, you're wrong. All right.
Did I? I don't know. I'm usually right in almost all the steps. Okay. Gosh. So you should have got 2 fractional answers that you could have left in fractional form. X is equal to negative 11/4 and 9/4. Did anybody happen to have both of those? Couple people, few people. If you did not, what was throwing you off? Did you isolate the absolute value first? What? You added 6? Ooh, okay, so let's talk about that. So if you have 6 here, how do you know what to do with it? What is the sign on the 6 right now? It is a positive. So the only way to move that mathematically, because it's positive, is to subtract. So always make sure is whatever you're doing, if you said 6 plus 6, that's not going to get rid of the 6. So be careful on those. But I appreciate your saying what it was that you missed. Okay, anybody else? You see what you did, what you didn't do? And why do we set it equal to the positive value and the negative value? Why do we do that? Because whatever is in this absolute value is 10 units away, and we know that it has to be 10 or negative 10 is my answer to this expression. So we set those up as equations and solve, okay? All right, let's see if we can do one example here. Actually, we can probably get both done. So let's go to page 17, the old 17er. 17. We are taking one more step. Math is very methodical. It's built upon steps. So hopefully you have a pretty good understanding of what we've done so far. We are moving on now to inequalities, absolute values with inequalities, okay? Very similar with one extra little thing. So up here towards the top, I want you to put when setting your absolute value equal, and I put equal in quotation marks because it's not really equal. When you are setting that equal to the negative value, comma, you will flip the inequality sign. Because we are putting it equal to a negative value. So if you remember, when we multiplied or divided by that negative value, that's when we flip the sign. We are also flipping the sign here. Now, this all says the same thing, but a much more mathematical content way. So that's why I thought, let's just write it like this. But you can see, here's our original problem. Absolute value of ax plus b, end of absolute value, is less than c. So the first one, it's isolated. My first case says ax plus b is less than the positive value of c. And here is my second case. Down here, ax plus b, we flip the sign, flip, is greater than negative c, okay? Again, we do the same thing for the second problem. Here's the first with the positive, here is the second. We flip the sign when we set it equal to the second. So let's try an example. Example 5. Come on, people, stay with me. All right. So absolute value, 4x minus 8, end of absolute value, minus 5 is less than 11. Is this isolated? This absolute value, is it isolated by itself? Survey says, I can barely hear the survey. Survey says, now I hear nothing. No, it's not isolated. What would I need to do here? Lanisha, what would I need to do here to start solving? Add 5, very good. Add 5, whatever you do on this side, you have to do on the other side. 5s cancel out. So I have the absolute value of 4x minus 8. End of absolute value is less than 16. Now it's isolated. It is all by itself. So I can separate into my two cases. 4x minus 8 is less than 16. That's the positive case. And 4x minus 8 I'm going to set it to negative 16, but what do I have to do? Flip the sign. So that's why I'm putting it in a different color. And you might circle it or put an arrow to it or star it so you know that is a big difference to flip the sign. Right, Emery? Jamila? Woo! All right, now I have no room to solve, so I'm going to rewrite it up here. 4x minus 8 is less than 16, and 4x minus 8 is greater than negative 16. Add 8, add 8. 8's cancel. 4x is less than 24. Divide by 4, divide by 4. X is less than 6. We have to graph this too? Oh my gosh. Is that going to be an open circle or a closed circle? Open, yeah. So on my number line, I'm going to go to 6 and put an open circle. And I'm going to just start it out to the values that are less than that, because I don't know what my other value is going to do yet. So on the other side, I add 8, add 8. Again, get a calculator if you're not good with your positives and negatives. 4x is greater than negative 16 plus 8 gives you negative 8. Divide by 4, divide by 4. X is greater than negative 2. Again, that's going to be an open circle on negative 2. And I want values greater than negative 2. So look, all these values in between negative 2 and 6. Are negative 2 and 6 included? No, because they're open circles. They are not included. We call this an AND statement. AND statement. So I'm going to put the negative over here first and say x is greater than negative 2 and x has to be less than 6. So that is your written solution. Okay? When you have these inequalities, you're going to have what we call a, what did they call it up here? Compound inequality. You're either going to have an and one or an or one. The next example is an example of the or. This will be our last problem of the day. So again, we're still dealing with isolate and separate. Is this absolute value isolated? No. Should I undo the multiplication or should I undo the subtraction? Anthony, what do you think? Should I undo multiplication first or undo the subtraction? Here's multiplication, right. I should undo the subtraction first. So it is being subtracted by 6. I'm going to add 6. Add 6. 6's cancel out. 3 times the absolute value, 4x plus 2, and absolute value is greater than or equal to 15. Now it's being multiplied. We do not distribute with absolute values. We do not distribute. So I divide by 3, divide by 3. I get the absolute value 4x plus 2 is less than or equal to 5. Now it is isolated. Now I separate into my two cases. A 4x plus 2 is greater than or equal to 5. It's exactly as that is written. And on the other side, 4x plus 2, I'm comparing it to negative 5, which means I had to have divided by a negative, so I am going to flip the sign. Flip that sign. And now we solve. Minus 2, minus 2 cancels out. 4x is greater than or equal to 3. Divide by 4. X is greater than or equal to 3/4. Can we have a fraction? Yes. Yes, we can. This would be a good place if you want to change it to a decimal to know where it's at, to change it to that decimal. And I am saying that x is greater than or equal to 0.75. Is that an open or closed circle? Should be closed because we've got that equal sign. So a closed circle on 0.75. 0.75 is right in front of the number 1. And I'm going to let people know this is 0.75 or 3/4. On the other side, subtract 2, subtract 2. 2's cancel out. 4x is less than or equal to negative 7. Divide by 4. X is less than or equal to negative 7/4. Yes. That is, if you use your calculator, negative 1.75. Negative 1.75 is right in front of negative 2. Negative 1.75 or negative 1 3/4. Now, let's take a look at the signs. Again, that's a closed circle. This first one says x is greater than 3/4. Greater than. So that means it should be going out. It's bigger than 3/4. This other one says x is less than negative 7/4. If it's less than, I want values that are smaller. We call this an OR statement because this looks like a pair of rowing oars. See how they're going out? Okay, it looks like a pair of oars. So this is an OR statement. So we have on the bottom side, x is less than or equal to negative 7/4. That's this side. Or x is greater than or equal to 3/4. So the OR statement has the arrows going out. It looks like a pair of rowing oars. The AND statement above has them both going in. Okay? Any questions about those? Hey, we are done. Your homework tonight is 9-2, Module 9, Homework 2. I would like you to do the front page at the very least, and you probably could start on the back page now too. It is due Wednesday. So get a head start. Do the front page tomorrow. If you have questions, we can go over your questions, okay? How are you feeling right now about absolute values, either with equations or inequalities? Thumbs up, thumbs sideways, thumbs down. Come on, guys, show me your thumbs. Nobody else is looking. Just show me your thumbs. Okay. Up and sideways. That's what I see mostly. All right. So, tomorrow, this is homecoming week. Our football team won their first game of the season, right? They did win. They did win on Friday.
what was it, like 20 to 20 something? I don't think we won. I think we only got like 20 something.
That's okay. That's.
Like 46.
I don't know what. I don't remember what the score was. We won.
46 to 14.
It's homecoming week, spirit week. Tomorrow is mix and match day. So I challenge you to let's bring a little bit more spirit back to Pike, okay? So you didn't dress up as Ursula today. Not everybody can wear this costume, right? You can say that again. So wear 2 different colored socks. Wear 2 different shoes. Wear a patterned shirt with striped pants. You can't do this every day. Take advantage of it.
Actually, I think we could.
You think you could?
I could wear mixed match socks or different shoes every day if I really wanted.
You're probably right. But tomorrow, nobody should be able